So, as I said, today is day 1 of trig. Okay? So, we will basically, the way we do trig is, again, the way that we've done it in the past. We used to have a textbook, and so chapter 4 in the old textbook was the start of trig. So if you see stuff with the reason why today your first real trig unit is 4.1 is because it used to come out of chapter 4 and it was section 1. Okay? And so we take these sections of the textbook and we break them down into parts of them. Or so like each section is kind of like its own little chapter. All right, so you have been dealing with rectangular functions. FYI, notes are on your own in your own notebook today. I failed to mention that at the start too. So you're on your own today in your notebook. Okay? You have been up to this point in time dealing with rectangular functions. And a rectangular function is one that can be graphed on a Cartesian coordinate rectangular coordinate system. The normal grid. Y equals x squared. Right? Y equals mx plus b. All of those are rectangular functions that you've been dealing with up to this point. Okay? Little bit last year you started talking about sine, cosine, and tangent in your Algebra 2 extended class, and you developed the unit circle, etc., and that's great. We'll do a lot of that this year. We'll start developing the unit circle here relatively quickly. Okay? A trig function is different. A rectangular function takes a number, you put it in the function, and you get out a number. Okay? A trig function takes an angle measure, and that is your input, meaning it's your independent variable. The angle measure is. And then you get out a real number. Okay? That's what a trig function does. So it inputs an angle measure either in radians or degrees. And then you get out a real number. One of my goals is to make sure you guys have enough time to write stuff down. So that's why I'm pausing here so you get stuff written down. Everybody got it? Suppose I need to get out of the way, don't I? Tweaking stuff over here. Okay? All right. So, in a circle, does anybody know why there's 360 degrees? There's 360 degrees all the way around a circle. Anybody know why? Okay. It's actually kind of cool. It was developed way back in Mesopotamia. So way back in the countries now of Iran and Iraq, that was the Mesopotamian basin there. The Sumerians and the Babylonians said 60 is a pretty cool number because 60 can be broken up into so many different parts. Okay? It can be broken up into 2 parts, 3 parts, 4 parts, 5 parts, 6 parts. 10 parts, 12 parts, 15 parts, 20 parts, 30 parts. Okay? So many different numbers can go into it. And a lot of those numbers that don't go into it can still be reduced fractions. Okay? Yes, they were doing fractions way back then. Okay? In Mesopotamian time, in the ancient times. Okay? So this system was chosen for its many divisors, which makes calculations with fractions a lot easier. Okay? So that's why it's 360 degrees. Okay? Some measures of degrees that we have out there in or on the old unit circle. So remember that on the unit circle, we start at 0 degrees. To go all the way around then, it would get us to 360 degrees. Halfway around then would be 180 degrees. Then half of half would be 90 degrees. Half of the other half would be 270 degrees. Half of the half of the half. Okay, so half of the half of the half would be 45 degrees. So then this would be 135, 225, and 350. Remember, in pre-calc / trig, 0 is straight out to the right, and we go counterclockwise. Okay? Second semester, when we get into navigation and vectors, we're really going to screw you up, because then we're going to go off of a compass, which has 0 at the top and goes clockwise around. Okay? Second semester, we'll have 4 different angle measures for one angle. Okay? Or we'll be able to say the same angle in 4 different ways. Okay? Good to go on that? All right. So, now what I need you to do is on the back side of that piece of paper that you're using right now, smack dab in the middle of the middle. So like right in the exact middle of the paper, I need you to put a dot. Okay? So as close to the middle of your piece of paper as you can get, put yourself a big old dot. Then what I want you to do is I want you to draw, using that straight edge, draw a line to the edge of a paper. Now, I say this next. Each of you is going to get a sleeve of Smarties. Please do not eat them until I tell you to eat them. Okay? We will get to eat them. Okay? I promise. But don't eat them now, because we're going to use them now. Okay? I have rulers up there. Again, don't eat your Smarties yet. We'll get there, promise. Okay? You need to open up your Smarties, though, and you need to pull out 6 or 7. I don't care which one you go with, and it depends upon the size of your paper. If your paper is smaller or your notebook is smaller, then you definitely want to go with 6. If not, go with 7. Okay? Then, what you're going to do is you're going to take your Smarties and you're going to line them up, starting right there, smack dab in the middle, along your line. If you go 6 wide. If you go 7, go 7 wide. But you're going next to one another all the way across until you get to 6 or 7. Try and get try and make it go through that diameter part, so that it's kind of, that you're consistent and all that fun stuff. Okay. I chose 7 because I got a big board. Okay. All right. Now, next, what you're going to do is you're going to mark that edge. Okay. So once you get that Smartie radius, if you will, you're going to mark that edge right there of your Smarties. And then you can move your Smarties to the top of your paper, because we're going to have to do something here first. Okay, so once you mark your Smarties, then move them to the top. Now, all of you have compasses, and I apologize for the high qualityness of these compasses, because we had a bucket of good compasses in here, and we don't know what happened to it when we had to clean up the room last year. So I got to go try and find it this afternoon, because foreign language probably up and stole our compasses and our rulers. That's why we got the paper rulers today too. We had all this good stuff, and we don't know what happened to it in the movie. But such is life. Okay? So all of your compasses have this little knob up here at the top. Okay? That's what you use when you're making your circle. That's where you hold your compass. So you're going to set your distance on your compass and then hold up there, put a little pressure on. Now, those of you that are using loose leaf paper, it might help to put a couple more sheets of paper underneath and draw yourself a circle with that radius that you had of your Smarties. So you should have a circle on your paper now with the radius of your Smarties. Well, because you didn't grab onto the top. It also helps to put, this is what happens is so you put that pointer there and then go around. Okay? Right? Everybody got that? Now, what I want you to do is I want you to take that same amount of Smarties that you just had for your radius. I want you to take that same amount of Smarties, and I want you to start measuring on the circumference of the circle, starting at your line, where your line intersects your circle, all the way around. Okay? When each time you get to your radius, put a tick mark down. Okay, so there was one. I went 7 Smarties, so there's one. So I'm going to put a tick mark right there. And then I'm going to start measuring from that tick mark until I get all the way around my circle. Everybody understand? Go for it. So, you should have found that when you went around the circle, you ended up with 1 there, 2 there, 3, 4, 5, 6, and then you should have had, if you did it right, you should have had a little gap coming back, or a little gap there. And it should be fairly close to, oh, tap the brakes, I grabbed the wrong thing. it should be fairly close. Mine was off by just a little bit. It should be fairly close to 2 extra Smarties in that gap. Okay? What you just found was you just developed the concept of a radian. Okay? A radian is an angle measure that the central angle theta intercepts an arc of that radius. Okay? Now that's fancy math speak. Let me show you what it means. Truly, a compass is a measuring device. It is not just a circle maker. A compass is actually better than a ruler. And so what it does is it measures that length of that radius. So if I were to walk, if this were here in the room, I could be standing at the center of the circle right now, and I could walk 7 Smarties over here, or 6 Smarties, or however distance over here, and that's my radius. Okay? A radian takes that same length, but now converts it onto the circle so that this angle here that one's way too big. Bring that down a little bit. There we go. I like that better. Okay? So that this angle here is 1 radian. This distance here is 1 radius. Okay? So 1 radian makes the same distance as a radius here along the circle. A radian is approximately 57.3 degrees. Because, as you'll find out on Friday, when we convert degrees to radians, we're going to do that on Friday, in a full circle, there is 360 degrees. In a full circle, there are 2 pi radians. The symbol for a radian, just like the degree symbol, the symbol for a radian is a lowercase r up in that exponent spot. Okay? So if you take 360 and divide it by 2 times pi, you would get approximately 57.3. Okay. Talked about that already. We don't have to talk about that. So, what is the measure if that's the case? So let me go back to this slide here 1 second. If that's the case, if the green squiggly distance is the same as the blue and red distances, because those are both radii of the circle, if that's the case, green is equal to blue is equal to red, if that is the case, now here is my green. Here is my blue. How many radians is this central angle theta? If my arc length is 20 Smarties long and my radius is 10 Smarties, how many radians would that be? How many radians? Let me say that in a different way. How many radii, because that's the plural of radius, okay? How many radiuses did we go to get the green? We went 2, right? So how many radians is that central angle? 2, right? Okay, because back here it said, measure the central angle that intercepts an arc is equal in length to the radius. So if I went 2 radiuses, that means I went 2 radians in terms of that central angle. So this would be 2 radians. Or you could write it as 2 rad. Okay. Or you could write it as 2 radians. What can't you write it as? No? What? So I can't write it as 2, right? I can't just write it as 2 because I don't know what 2 is then. I don't know if 2 you're talking about degrees or radians. Okay? So we have to label our units, especially when we're dealing with just numbers. Later on, typically a radian measure is going to contain pi in it somehow. And if we see pi in it, we are going to make the assumption then that we're dealing with radians. Okay? 2 doesn't have pi in it, so we have to label that which it is. Okay? So, if we're finding an arc length, and an arc length, actually, let me go back to this one. We'll go back to this one first. So, if an arc length is equal to, or if the central angle gives me how many radians we went, then the central angle times the radius would give me that arc length. So the formula that we're dealing with here is S is equal to R times theta. S equals R theta is our formula, where S is the arc length. That was my green. R is the radius. Actually, here, so I'm not. And theta is the central angle. But the kicker is it has to be in radians. If it's in degrees, we can't use R equals, or excuse me, theta, S equals R theta. Off of the other ones. Okay? So if we have here, our central angle is 1.5 radians. I can use S equals R theta. We have the arc length, we have the radius, S equals R theta would just be 8 times 1.5, and 8 times 1.5 is, I believe it's 12. We don't have any units in our distances, so we're just going to leave it then as S equals 12. Questions, comments, concerns, clarifications? Okay. Kicker here is we gotta make sure that we memorize S equals R theta. Okay. With that being the case, what happens if we do have an angle measure, a central angle measure of theta in terms of degrees? Well, for right now, okay, until Friday, because that'll be the next time we have class, we'll convert degrees to radians and radians to degrees. But for right now, luckily for us, 90 degrees is how much of a circle? It's a fourth of the circle, right? Okay. So I can still use S equals R theta, where I can say that R here is 15, and theta is 1/4 of 2 pi. Because 2 pi is the radian measure to go all the way around the circle. "15 times 1/4 is 15 fourths. 15 fourths times 2 pi is 15 pi over 2 units, because there is no label in this problem. Okay? This will get easier for you. This will get easier for you come Friday when we're going to talk about converting. If you understand the conversions or remember the conversions back from Algebra 2, or just know them from a science class, by all means, go with your bad self, okay, and get her done, okay. So right now, what I need you to do is, if you didn't talk to NTC at Conflict Resolution Day, okay, they were onboarding kids and they were enrolling kids in the dual creditness of this class. They are here today, okay? They're down in the community room off of the Commons, okay? So if you didn't talk to them on Conflict Res Day, I need you to take your Chromebook with you to the community room down in the Commons and get registered for this class, okay? If you did that already, then the floor is open for the next mod for Chapter P questions to get prepped for your test tomorrow. Okay?